Hello, this is Mr. Reynolds, and today we're going to learn about the hydrocarbons. That's hydrocarbons, okay? And um, these are considered to be the backbone molecules of all of the organic compounds. And you learned before, organic compounds were ones that contain carbon, right? The only elements we'll be dealing with will have carbon atoms in a chain, and hydrogens will be bonded around those. Okay, we're doing a type of hydrocarbons that are called the alkanes. ANES means there's all single bonds between them. Okay, between the carbon atoms. Alkenes, which you will encounter some in class. ENES means there's double bonds. Alkynes means that there are triple bonds. Okay. Anyway, like I said, the only thing we're dealing with is hydrogens and carbons bonded together. And that's it. There's no sulfur, no oxygen, no chlorine, no fluorine, just hydrogen and carbon. Okay. The first and simplest one is considered to be methane, which you've already experienced in the lab some. It's one carbon atom bonded to 4 hydrogen atoms, and it's covalent bonds, which is really, really, really strong. Okay, so one carbon atom bonded to 4 hydrogens around it. Okay, and what you learned before with Bohr models is that hydrogens have 1 proton, 1 electron. Man, if it just gets a second electron, which it does by sharing, it would have 2 on the first shell and be very, very content. Bohr models of carbon that you already know. It's got 6 protons. Its mass is 12 when you look at the periodic table, so it means it's got 6 neutrons also. It's in row 2, so it's got 2 shells. Like I said, you've done all this. Okay, it's got 2 electrons on the first shell, 4 on the second, and that works. We find it in tall column 4 on the chart. And I'm going to do this one again, because then I'm going to bond it. 6 protons, 6 neutrons, 2 electrons on the first shell. And I'm going to spread out those 4 electrons that hate each other's guts, okay, because they're all negatively charged. So we're going to spread them out. All right. When we do covalent bonds, which a lot of energy is involved with that, we're going to overlap the orbitals. Okay, this is a hydrogen. You can see by the +1. Here's the electron from the carbon. Here's the electron donated by the hydrogen. Okay, and we're going to do that 3 more times. Here's my hydrogen. It shares with the electron from carbon and donates its own to the sharing. So its electron goes flying around the carbon atoms also. The carbon atom's electron flies around the hydrogen. Okay. And notice how we're overlapping. We do that so we can show the sharing. Here's the electron from the carbon. Here's the electron donated by the hydrogen. Okay. And my fourth one, here's the electron from the hydrogen. Here's the electron donated by the carbon. So right now, carbon thinks it's got 8 electrons flying around it. Okay. Hydrogen thinks it's got 2 flying around in its first shell, so it's stable and content. Carbon has the stable octet, so it is good to go. All right. The chemical formula of any substance is going to tell you what's present, carbon and hydrogen, in this methane. Carbon and hydrogen, there's 1 carbon, so it just stays 1 understood, and there are 4 hydrogens. So the chemical formula tells you what is present and how many of each. All right. This diagram that I drew here is said to be the structural formula. And the structural formula of any substance shows you the arrangement of the atoms. And in this one, it's 1 carbon in the center, surrounded by 4 hydrogens. Okay. Let's go to our next slide. F means 2. ANE is single bonds. So we're going to have 2 carbon atoms covalently bonded to 6 hydrogens. So 2 carbon atoms in the chain, single bonds. Each carbon wants to be bonded 4 times, so I'm going to have 3 hydrogens around it. Carbons on the end get 3 hydrogens around them. Okay. This is my structural formula. Shows the arrangement. Chemical formula is C2 times 2 plus 2. 2 times 2 is 4, plus 2 is 6. Okay, that's how we figure out the number of hydrogens around it in the alkanes. All right, next is prop. Prop means propane. If you see people living out in the country, they're not on the city gas line, which is methane gas. They're probably going to have a propane tank in the backyard. Okay, it's colored silver, and there's pipes underneath the ground that lead into the house, and this is what is burnt to heat the home. Okay, so it's propane. Prop means 3, so 3 carbon atoms in a chain. A and E is single bonds. The carbons on the end get 3 hydrogens because they already have carbon bonded once to the other carbon. This carbon on the other end is already bonded once, so we're going to put 3 hydrogens around it. Okay. Carbons in the chain. A carbon atom in the chain already has 2 bonds, one to this carbon, one to the other carbon on both sides of it. So I got 2 bonds. It only needs 2 more hydrogens, so we're going to put those around it. All right. So here's my structural formula, and my chemical formula will be C3. H times 2 plus 2 is 8, or you can count them up. 1, 2, 3, 4, 5, 6, 7, 8. All right. Next is bute. And we're going to be sketching butane, all single bonds. Bute is 4. People use it, taking stoves for camping or lanterns for camping. A lot of times it's butane they'll have in it. They used to use butane a lot in cigarette lighters. Like I said, it's 4, so 4 carbon atoms. The ones on the end get 3 hydrogens. The ones on the end get 3 hydrogens. The carbon atoms in the chain are already bonded twice, so they're going to bond onto 2 different hydrogens. Okay, so structural formula is this. This is what it looks like. Chemical formula is C4. H times 2 plus 2 is H10. That's my chemical formula. All right, and before we go to 5, now you start recognizing the prefixes. Okay, so pent is or pentane. 5-sided figure is pent. A and E is single bonds. 2, 3, 4, 5. All single bonds between them. The carbon atoms on the end get 3 hydrogens. Carbon atoms on the end get 3 hydrogens. Carbon atoms in the chain are bonded to 2 hydrogens. Again, whenever you see this line, the line between them means sharing electrons, covalent bonds, lots of energy. I'm going to neaten up this little carbon. Okay, so chemical formula is C5. H times 2 plus 2 is H12. Structural formula, this is what it looks like. Chemical formula, what's present, how many of each. All right. 6. Hexane. Years ago, in 1980 or 1981, the Ralston Purina Company released some hexane into the sewers. By the time they called up the city, some of the sewers had already exploded in downtown Louisville, and they had to close off some streets because most sewers ran underneath the road, underneath the asphalt, and so some of the holes were big enough that cars were going to fall in it. So they blocked off the streets, and the chunks of asphalt that blew up, a lot of them went through some store windows. So like I said, they had to cut, they had to close off some of the city streets. If you ask your grandparents about that, they'll probably remember. So hex is 6, so 6 carbon atoms, all single bonds. We're going to start to get lazy here. If you ever see a hydrocarbon written like this, wherever there's dashed lines and nothing else attaching, it's hydrogens, okay? If it's anything other than hydrogen, they have to put that, all right? So C6H times 2 plus 2 is 14. So chemical formula, C6H14. Structural formula, it looks like this. Okay. Heptane is going to be 7, all single bonds. Okay. 2, 3, 4, 5, 6, 7. Staying lazy with it. 3 hydrogens on the end, 2 in the chain. I'm just putting the dashes, which is covalent bonds, and appropriate to do that. C7 times 2 plus 2 is 16. Chemical formula, C7H16, and what it looks like, its arrangement of the atoms, is that. Okay, octane, 8 is octane. Octopus has 8 arms. Gasoline, you will usually have an octane rating. It helps the gas to burn better. So that's going to be 8 carbon atoms, all single bonded. And surrounded by the hydrogens. 3 hydrogens on each end, 2 hydrogen atoms in the chain. Okay, C8, H times 2 plus 2 is 18. Chemical formula, what's present, how many? What it looks like is its structural formula. Okay, 9 is no name. And we're going to move on to the next one. 10 years is a decade. We've been saying a decade of the rosary. Decane means 10 of them. Okay. 2, 3, 4, 5, 6, 7, 8, 9, 10. All single bonds. The ones on the end have 3 hydrogens. The one in the carbon atoms in the chain have 2 hydrogens each on each side of them. Okay, this is my structural formula. Chemical formula is C10. H times 2 plus 2 is 22. And a big deal with all of these hydrocarbons is that now hydrogens can be taken off and other molecules substituted in there. So when you keep studying what living things are made up of, like you're made up of proteins, forms a lot of your structures. You burn carbohydrates. We store lots and lots of energy in lipids, which includes fats, oils, waxes, steroids, and cell information, DNA and RNA, is in the form of nucleic acids. Okay. All of these are considered to be biomolecules, these 4 biomolecules, but they have their basis, their start with the hydrocarbons. Okay, so that's why we're starting to study these, and we've done the first 10. So you want to take some decent notes on that, and we are done with this. There are some questions you need to answer. I'm going to put this last slide on here. And it tells you where to find some questions that you get to go answer in your OneNote. Thank you very much. Bye.